Hi everyone, welcome back to Architecture 5610. This is Tyler Young, and in this video I'm going to show you a bunch of tips and tricks with 3D commands within Rhino. I'm sure that you know some of these. I'm hoping that some of them may be new. So as we get started, I did see some people struggling to zoom in and out on things. Sometimes the scroll wheel just doesn't do it. If you select something and you type ZSA, that'll take your screen right to it. So this isn't really a 3D command that I want to show you, but it is super useful and can be used on every type of object from curves to poly surfaces and everything in between. So the really simple command here is array, and that's going to give you a grid kind of similar to what is down here. So it asks you for a number in the X, Y, and Z direction. I'm just going to do 2, so that way we keep this small on the screen. 2 again, and I'll go 2 in the Z direction. So first you're going to have to click a point, and then you can type a distance. So I'm just going to say 10 feet, or 10 inches rather. And then I'll go 10 inches this way. And then I'll go 10 inches vertically. Or maybe I'll go 20 inches vertically. And then I'll hit enter. So it is asking if you want to press enter to accept. So you could still kind of go back in and change these. So if we want to change that number in the X direction, we could change that to 3. And before we actually commit to this, it gives us that option to expand that grid a little bit further. So that's enter, and that is the array command. The next command is extremely useful, and it's very similar to the array command, but it, rather than doing a grid, it will do this along any kind of curve. It doesn't need to be a closed curve or a circle like this one, but I think this is the most straightforward way to show it to you. But yeah, this is a really powerful command here, and if you ever get into Grasshopper, you can really write a script in I don't know, 20 seconds. That would make this parametric, and we can get into that later this semester. So right now it's asking, how many items do you want? So 2 in this instance is pretty useless. I'm going to say just 22. Why not? And so now you can see that these, not only are they copied all the way around this, but they're also oriented in a very nice uniform way and symmetrical way around this curve, and I didn't need to go through a bunch of steps. What you will see is that the distance is being kind of pre-calculated, it looks like, and the orientation is set to freeform. You can do road-like, you can do no rotation, so no rotation would just move it and it would stay in that same orientation. Road-like, let's take a look. Kind of looks like how it did before. And let's just try that again because I accidentally hit escape. Freeform. Let's change that to 22. So yeah, definitely experiment with the freeform and road-like. Sometimes it's hard to know the difference between those, but I think with open curves it would make a little bit more of a difference. So next I want to show you guys a few commands that are just really simple kind of 3D manipulation commands, and that's like really these 3 up here. So they are what they sound like. You can kind of taper something, you can twist something, and you can bend something. They are a little fussy to use. I honestly don't use them that often myself, and the interesting thing is you can make these kinds of shapes with other commands that I'll go through later in this video. But so to show you how it works, so the bend command is going to ask for a spine to use. So I'm just going to pick kind of the edge of this geometry along the midpoint. I don't think it needs to be the midpoint, but it's a nice kind of central point to the geometry. Also, you'll notice that as you do this, you'll get all these crazy lines and it looks really weird. So if you select them and you're in the properties tab over here, you can just turn those ISO curves off. So it's a little bit nicer to look at that. Twist is kind of another they're all kind of the same thing, which is that they're a little awkward to use at times, but the more you kind of practice how to use them, the easier it'll be. So, and as with everything, you just want to really pay attention to the prompts up here at the top left. So I'm just gonna pick a point and we can see what happens. I'm doing the taper and not the twist. So twist, here we go. So start of the axis, and then I'm gonna pick that point down there and you can see what's happening here. So if you go a little too far, these can start to intersect themselves, and then things get really weird really quick. So like you won't be able to 3D print it kind of a thing, or if you wanted to, you wouldn't have as easy of a time as if it was just a regular piece like this. So that's an extrusion. These sometimes, if they intersect themselves, things get weird. I won't get into it, but so here's the taper command, and it's all three of these are kind of, it's like they're the same, but they're not. But they always kind of want an axis or a spine, and then they kind of want a reference point, and then, you know, maybe you can just type in a distance. So if I say 7, you know, that's larger than my object, so you can go wider or you can go kind of skinnier. And so yeah, that's really those three commands, but you really just have to play around with them and pay attention to those prompts up here in the command line. So the next command, this one is super useful if you're just making a whole lot of walls of the same thickness. And you really do need to have that thickness like predetermined. So I just typed in slab, and the distance right now I'll do 1, and I will click this curve here. So what slab is, it's essentially offset to one side but also extrude simultaneously. It's like a offset plus extrude command. So I'm just clicking inside, and I'm gonna type in a number of 5, and there we go. Now we have something solid, and I'll just turn those ISO curves off. It does kind of do a weird thing with how it creates its corners. If you extruded that after offsetting it, you wouldn't have this seam here. We could try typing in merge all coplanar faces. So there you go, that worked. So this command here is spiral. It is definitely what it sounds like, but it is a curve-based command. I'm showing it to you kind of in the context because potentially pipe can work really well with it. So if you do the spiral command, you can basically just type in spiral. You can draw an axis, and you can also prescribe a diameter or a radius. You can say how many turns in this spiral. You can give it a pitch, like the kind of the slope, sort of. You can reverse the twist to go the other way around. So this is really useful in situations where you're trying to replicate something like a spring or a pigtail of some kind. But so what's really great is now you can select something like that, and you can use this next command, pipe. And what it does is it creates a solid tube. You do want to, as with everything, check these command prompts up here. So do I want a cap? Do I want that cap to be flat, or should it be round? A couple different things. Fit rail, you can kind of test with that. And output surface, diameter. So I'm just going to say the start radius of 0.25, and I'm just going to hit enter again, and it usually defaults to keeping the same radius. You do want to pay attention to that, or if you have like grid snap or some kind of object snap, you might accidentally click and it will do something else. But so the domed kind of rounded end would be, you know, what we see here. And then here's something that I already used, the pipe command. And if I use pipe on this one here, I will go to the flat cap. You could also do none, which would just make it like a hollow surface and not a closed poly surface. So here we go, hitting enter, and there we go. And we got my kind of knot of line work creating a pipe. So really fun one, really easy to use, really powerful if you've got some good line work to start from. So next I'm going to hop over here to these Boolean operations. Boolean operations, the buttons are all over here. The Boolean union kind of just joins things together and makes them into one monolithic solid. So this here is a closed solid poly surface. This is a closed extrusion. I could click both of these, and this button here in the front is the Boolean union one, but to show you the menu, it's the first one here. Now they're joined together, and if I use that merge all coplanar faces command, you'll see that they are now completely joined across. So the Boolean difference command is kind of the opposite of that. So if I make this object intersect with the other, I can now use the Boolean difference command, which is from the drop down this second button. And so it says select surfaces or poly surfaces to subtract from. So whatever you want to cut out of. So if I want to notch in this thing in the middle here, I hit enter, and then I select my other object, hit enter, and now if you move this other object, you can really see that I have removed a little notch using where this object and that object were intersecting. So next is kind of a similar thing, but Boolean split. And you can also just type this in, Boolean split. So select surfaces or poly surfaces to split. If I just want to split this one, I hit enter, and I select a cutting object, hit enter, and then I pull this one out, and now you'll see that I've just removed that little slice without interfering with this. So the Boolean intersection is essentially you have two solid volumes, you select them both, you do the Boolean intersection, and now it just gives you where they overlapped. So if I were to replicate that again, I can stick these two together, use Boolean intersection, hit enter, and now I'm just left with where they overlapped. Another really fun one is the shell command. So shell basically turns anything that is a big solid object into a sort of box with an open top. But it's actually a little bit more powerful than that. So here all I had to do was select the one face that I wanted to be open, and I had to give it a wall thickness. And you have to watch out when you're doing this because the wall thickness is very particular. It definitely needs to have more size to the original object. So this is 5 and some inches wide. If I do this shell command and I go with, say, 3 inches, it's going to probably yell at me and say that it failed. But so if I try this again and I make sure that kind of, if I were to double this, that it's less than half of the width of my object. So I'll go with 2 and we'll see how well that works. It might have a harder time, but it seemed to work just fine. So the interesting thing as well is if you do Boolean, or if you do shell on something that's Boolean unioned, let's try it. You can just make a giant cavern throughout all of it. So I will make this a much smaller number. So I'll go with 1/4 inch. And I'm going to use the shell command on this thing that's been unioned together. And now you can see actually that I have hollow all the way throughout all of it. Really good one. Really powerful command. But it requires things to work a certain way, and if they don't work, then they don't work. So then you'll have to find a different way to do it. So that's all the Boolean operations, but all of those buttons were in here. So the shell is this one on the top right, split, intersection. There's a whole lot more that are probably used a lot less commonly by me at least, but they're all really great and worth checking out. So what you might notice with anything that's a manufactured object is that it's probably not going to have sharp corners like this cube or any of these cubes I have modeled where it's all like 90 degrees ends at a kind of point. If you look at most things, they're going to have a radius kind of filleted edge or a chamfered edge. So if I just use the command chamfer edge, what you'll see is that as I enter this command, that unit 3 that it was defaulting to, as you'll see again right here, there it said 3. So that number corresponds to the kind of depth and the width. It does not correspond to this kind of hypotenuse of the chamfer. And then, so chamfer is an easy one, but filleted edges are a little bit more complicated. So if you do fillet edge, and then you go with, I'm gonna make that like 3, and I'm gonna click this here, I'm gonna hit enter, I'm gonna hit enter again, and now I have this nice radius. But so the thing that's weird is if I hit spacebar to repeat that command, and then I want to do the same thing again on these edges, it's not going to work. And that's basically because the radius that I had existing was 3 inches, and then the radius that it wants to create for these new filleted edges are also 3 inches. And so it would have to make a domed or like a quarter hemispherical corner. And it can only do that if you do it all at the same time. And it works great if you do it at the same time. But if you don't do it at the same time, you're going to actually have to work around it unless you just want to undo what you've done, which I recommend doing that. But if you just make this like 2.8 inches, for example, from 3 to 2.8, it will work, but you'll have that little kind of rounded section there that's left over. So something to watch out for. But basically, as long as you kind of know what you're going to do, you just got to plan it out. So this is kind of this is always the interesting situation. Like, how do I deal with something like this? So I could probably just want to do all 3 edges at the same time. And then you can go a step further. Well, okay, well, what if I want this one, this one, this one, this one, and this one? Will that work? Yeah. So it actually works. You just need to do it all at the right moment. If you go back and you try to do this, and then you try to do this, less guaranteed. But it does seem to work pretty well. Now it breaks. So it's just a matter of keeping track of that and knowing what you're going to want to make chamfered ahead of time. So that's really those. The other thing that I will show you is kind of a similar like edge and face manipulation. It's kind of like cheating in Rhino. So you can do solid points on. Just type in solid PTON, and now all of a sudden it's kind of like almost like chamfering. I can move edges just by these corner points, and you can hit escape to close out of that. And you can also just type in move edge, and you can do the same thing, but you just need to keep really a close eye on how you're moving this. So if I just move this up, it will let me just kind of move it any which way, and now all of a sudden my almost cube is very not cube-like anymore. So if I try that again, hit enter, and I take a look at the direction constraint, I can go with vertical, which is probably nice, and then it just keeps things like right there in line. But if I'm trying to move this that way, I can't really. If I'm trying to move it left or right, I can't use the vertical one. So then what am I going to use? Am I going to use none, or first face normal, second face normal, average face normal? So you can go back and forth between any of these. What I often find is pick none and then use the near command to make sure that you're object snapping. And rather than clicking on the corner itself, click somewhere along the edge and then travel along that edge to make that movement. So move face is a really great one. It has that same tendency to kind of break your geometry if you're not careful. So that was moving everything normal in the normal direction constraint. If I go with none and then I just click randomly and then I move it over here, I can kind of mess my shape up, and things go from being, you know, a smooth radius along this edge to now it's smooth radius and then a transition, a sharp transition to another radius. So you just have to pay attention to that. If it's something that you're trying to maintain, you got to be aware of it. So before we get into these more complicated ways to make surfaces, let's just kind of recap. So you have this button here, which is surface from 3 or 4 points. So you can just do 3 points, hit enter. You can do 4 points, hit enter. You can click the arrow to pick from a vertical plane, a rectangular plane from corner to corner. You can kind of do the same thing, but do an edge first and then the width. You can click this drop down here and go even deeper, and it's just kind of, it's really just the same ones, but just accessible from the first menu. But you'll also see there is surface from network of curves. There is surface from planar curves. There are surfaces, what does that say? It said surface from 2, 3, or 4 edge curves. And there's also patch. There's all sorts of options in here. So now, over here with the loft command, loft is a really great and powerful command. It kind of does sort of an extrusion, but a sequenced extrusion where one curve leads into another and then into another and another if you want. So you can extrude a cube if you wanted to, or you can loft a cube if you wanted to, but really it's meant for more unique shapes like this and something that kind of sweeps or bends over as opposed to something that just does something super linear. And then as you hit enter, one thing to pay attention to is these are the seams. So you really want them to line up with each other if it can. If you can get them on the quadrant of these circles, it's great. You want those arrows to all point the same way, so they're all pointing down and kind of inward from where this curve is. And I'm just locating all of those to the quadrant of those circles. And that just kind of keeps my geometry a little bit cleaner. And then when you're doing this loft command, you need to make sure that you're doing it in sequence. You can't go first, last curve, and then the middle. You want to go first, second, third curve in the direction of the loft that you want the loft to travel. It can't always make really tight bends, but something kind of flowy like this works really well. As you can see there, I'm in the normal style. There's also loose, which basically just kind of doesn't hold itself super accountable to every little shape along the way. It starts and it ends where you want it to, but in the middle it's not quite there. If you go with tight, it keeps it really dead on with where those shapes are. And then if you go with straight sections, it's essentially as though you lofted these things one at a time. So like 1 to 2, 2 to 3, 3 to 4, all in a straight rather than in that big sweep. And then uniform is, I don't really use uniform that much, so I'm not as certain what it does, but it looks like it's trying to keep things in a very gradual change of dimension as it moves through it, but hard to say. But I'm just gonna hit OK. Sweep 1 is one of my most used commands, along with sweep 2. Really just the sweep commands are really great. So sweep 1 is nice if you intend to keep a geometry kind of the same as it moves along one like edge. So if you have a curve here, oh, actually you don't want to select that first. So that's like one of the end pieces. That's one of the end pieces. And then this is the rail. And so when you type in sweep 1 or sweep 2, it asks you the first command or the first prompt is for a rail. So you want to go the direction that you want it to travel is the rail, and then the sweep shape 1 and 2. So one end and the other end, and then you hit enter, and so it is just going to take that shape and take this other shape and carry them along one rail, kind of similar to how the loft operates, but just a little bit different. So there's freeform and road-like. There is global blending, and there's an ability to refit the rail and to align cross sections. If you can see, like, these are the cross sections. This first curve here isn't quite what I would say perpendicular to that one, so that's why that one kind of tilts, and then this one tilts, and then this one seems pretty perpendicular. But I often try to get those cross-section curves to be perpendicular between the kind of implied rail and the given rail. So I'm just going to hit OK, and then now sweep 2 is very much like the first one, except for it asks for 2 rails and then 2 cross sections, or two shapes. So the thing about sweep 2 is that if you want the geometry, if you want these kind of profiles to change as they move along the rail, then you can kind of change the shape of each rail. So like, we didn't have control over 2 rails on sweep 1. Now we have control over 2 rails. So I can hit enter, and as I was kind of talking about the cross-section curves, the slash is kind of a similar concept. You can add a slash here, and you can make it perpendicular, and you can try to keep things as controlled as you want. And you can hit enter. So if I hit enter again, there we go, it's done. So the thing about sweep 2 compared to sweep 1 is that if I were to use my control points on this curve, so I'm in 3D view, I've got the gumball turned on, I select this curve, and now I've got these control points. So now I can manipulate these points, and I can pull them way up into the air. I can make this thing really, really narrow if I wanted to. But so I'm just going to make it really huge, and then I'll do that sweep 2 again, and you can see that I was able to change it a lot between these two versions. So hitting OK, and now I've gotten this super, super thick pipe that goes from kind of narrow to slightly more narrow, but very wide in the middle. You'd never be able to do that if you used sweep 1. So that's pretty much it for those commands. I'm sure that there's a whole lot more that I could show you, and we will try to pick that up in the next tutorial. Thanks, guys.